A particle is released from rest in the following diagram. Find the velocity if the natural length of the spring is 2 meters. Okay, here this is a fixed now here. Just imagine now for the spring which is connected to here. Just imagine now I connected to some wall like this. Now here at the other end I connected one body we have connected. So I put some elongation. Natural length is given how much? 2 meters. Natural length is how much now? Is given 2 meters, but I extended the 1 meter. 1 meter extended. Now I released now. If I release now this body at some height, then what happens now here? It will fall down now. And still it is fall down because of the weight of this body. It is having a total length is 5 meters. That means what is the actual elongation? Tell me now. Initial length is 2 meters. Elongation is additionally 3 meters we have. Now here if you observe carefully, what are the forces acting on the system? You tell me now. Gravitational force and why is applied force? Why is applied force here? There is no applied force now. We hold it like that. Okay, so what are the other force now? Spring force is there. Now here are only two forces, that is gravitational force and the spring force. That's why we can apply the law of conservation of energy we apply. Tell me now here. Now if you have considered this point is A and this point is B we are calling. So tell me now law of conservation of energy at point A and B. So we can say this as UA plus KA, which is equal to what we can say now? Tell me now. UB plus KB. Yeah, tell me now here. UA. So we have considered this. I am considering as some reference line. So potential energy case we have reference line is required now. So UA. Initially the body is at this location, at this height. How much height? How much the H value? 5 meters. So that means potential energy is there now. Positive or negative? Yes, mg into 5 plus. And what are the other potential energies? You tell me now. Spring also have a potential energy. How much the potential spring is in half kx square. What the kx is the elongation. Elongation means extra length. Yes. So actually here this is total is how much now? 3 meters. Now here what is the given 3 given na? What is the 3? What is this value given? Total length is 3 meters. Natural length is how much given? That means how much the elongation? 1 meter is that only x only. Remember. So half kx square means what I mean now? X must be elongation only. Total length minus natural length we have to subtract, then we'll get elongation. So that is what will be now? Half kx square. X value how much now? 1 square. And initially the system is at rest only na? Released at rest. So kinetic energy 0. Next UB. What is the UB is a potential energy of a block. Potential, this block reference line, potential energy 0. Plus now spring potential energy is there or not? Yes, spring natural length is how much? 2 meters. We have total length is given 5 meters, means compression is there or not? If the compression is so elongation is there, means we have so we have x value how much now? Potential energy how much now? Half kx square. How much? 3 square plus kinetic energy. How much the kinetic energy? That is half m into v square. At the velocity of the point B, we should find now. Yeah, tell me now. So how much this value? Tell me now here. This is mg 5 mg plus k by 2. K value not given here, and which is equal to 9k by 2 plus what tell me now here of m into v square. Values not given. If the value is given, we'll substitute and we'll simplify it now. Here we need to get the finally v value we need to calculate. Okay. The given values we can we'll get the v value. Right. Yeah, we can keep like that.
First 10 minus by
Yeah.